two cells of EMF E1 and E2, where E1 is, that is EMF of this one is greater than EMF these two. Connected as shown. This is the cell, say terminal A, terminal B, terminal C. This is the cell, and it is connected. This portion between A and C is connected to the potentiometer. This is the potentiometer wire, and this is the potentiometer arrangement, and the cells are connected between P and Q, where PQ length of potentiometer wire is equal to PQ, and K is equal to potential gradient of potentiometer. So now this is the arrangement. K, potentiometer connected between, so when a potentiometer is connected between A and B, see the potential between, this is the A and B, this is A and B, potentiometer is connected between A and B, it means this is connected like this. So this circuit is not available now. So when it is not available, the balancing length seems to be J1, which we can call it as L1, between P and L1. P and L1. See, again I repeat once again, at balancing point, what this is the balancing point for this connection. At balancing point, this length, that is the length of balancing length, that is the length of balancing is the EMF of the cell. EMF of the cell, this we have to remember always. See, now this is not in connection now. This is the cell now. And this balancing length L1 is equal to EMF of this cell, or we can say V, potential L1 is equal to balancing length. How we get the balancing length? We throw we move the jack here and there on the wire PQ, and where we get the null diffraction, that is the balancing point, that is J1, which is at a length L1 from the wire P to this place. So VL1 is equal to EMF of the battery, and VL1 is what? Potential gradient into that length, that is this point is equal to K, potential gradient of the wire into this length. This is the potential difference, and that potential difference of this condition is equal to EMF of this cell, that is E1. First condition, that is when AB is connected and balance point is obtained. Balance point is found. So we have found the balancing point when this is not required now, because this has been connected through this, bypassing this one, it means no current will flow here, because even if it is connecting, this is a dead end, no current will flow, so we can remove this point. So this balancing length L1, the potential difference between this length of this potentiometer wire gives the EM of this first cell, or we can write simply E1 is equal to K into L1. Here the potential grade does not change, because the length of the potentiometer wire does not change, therefore K will also not change. K for this and K for this also same. For any length, K is equal to the battery EMF divided by the length. Since we are not varying the length, the potential gradient will not change. So this is our first equation. Let us go for our second equation. The balancing length, and that length, what is that length? That length L1 is equal to 300 meter. 300 meter. It is 300, it should be in centimeter. Because, okay, centimeter, 300 centimeter in this condition. First condition. Second condition, what? On connecting same potentiometer, the same potentiometer on connecting the same with the same potentiometer between point A and C. It means now we are connecting this to this point. This is between A and C, it is connected now. It is connected. It means both now we are moving the jack to somewhere like J2. This we can remove this one, because only this battery is alone, this is the balancing length. When these two batteries are connected, this is the balancing length. It means when we move the jack after connecting these two, when we move the jack at J2, we get the null diffraction, and that is the balancing point. And let this length be L2. This length be L2. So on connecting same potentiometer between A and C, now we have connected between A and C the potentiometer, A and C the balancing length, that is we call it as L2 is equal to 100 centimeter. 100 centimeter, whether we keep in meter or centimeter, all the same. 100 centimeter. Potentiometer, we can say it may be in centimeter or it may be in meter, whatever it is. We have to find the ratio of the EMF of first cell and the EMF of the second cell. Now let us, in this condition, this is the balancing condition. Now we can write, that is VPL2. This potential difference is equal to EMF of these both the batteries. VL2 is equal to K into L2, and this is equal to summation, this, because both the batteries are connected in series. And here you have to watch carefully, this is in a reverse polarity and this is bigger than this one. So net EMF, this length, this potential difference is equal to EMF of this both the batteries. It means we can say E1, E2. Since E1 is, this is greater than the E2, so this will be minus, because if this is positive, this has to be negative, and this is smaller than this one. The net EMF of these two, because both are in reverse polarity, E1 minus E2 is equal to K into L2. K into L2. So now we have to find out, this is the second equation. This point you must always remember, at balancing point, the length of the balancing length at balancing point, the length of the balancing length is equal to the EMF of the battery connected in the circuit. So this is the second equation. Now we have to find out E1 by E2. So we call it as the first equation, and this we call it as a second equation, dividing first equation by second equation, because we have to find out E1 by E2. So when we divide, this becomes E1 minus E2 divided by E1 is equal to K into L2 divided by K into L1. This cancels. This is equal to, this we can write 1 minus E2 by E1. 1 minus E2 by E1 is equal to L2 by L1. What is L2? L2 is equal to 100. L1 is equal to 300. Whether it is meter or centimeter, it get cancels. We need not worry. Let us keep it as meter. Whether we keep it meter or centimeter, all the same, because both get cancelled. In this case, we can write it as meter, and this will write as a meter. This is equal to 1 by 3. That is, we can call E2 by E1 is equal to, we take it that side, 1 minus 1 by 3 is equal to 2 by 3. That is, E2 by E1 is equal to 2 by 3. On reversing this one, this become E1 by E2 is equal to 3 by 2. This is the result. First is what we do, we connect through this one, then we connect both and obtaining the balancing condition. So the ratio of E1 by E2, that is E1 is to E2 is equal to 3 is to 2. This is the answer. The answer is 3 is to 2. Answer D is the right one.